Hi. Um, Today I want to think about programming languages. And don't worry if you know nothing about them. I will try to keep discussion as beginner friendly as possible. So yeah, let's start. And so about me a bit. I started my career as a self-taught developer. And while I've managed to learn a lot of things myself, but still I had many unanswered questions. And I thought, like, maybe university degree will help me to find my answers. So I got a degree and gave it the answers. How do you think? Not really. Not really. So that's why very soon I realized that no one will feed the knowledge to me. And the main way to understand things is by asking questions and then trying to find the answer myself. And and that's exactly what I'm trying to do here. To find answers to the questions that bother me. So, what is our subject for today? Let's start from some small presentation. Let's go to our canvas and one thing bothers me occasionally. If not friend, why friend-shaped? Why fluffy ears? It's like designed to break our self-preservation circuits in our brain. Or why so fluffy? But okay, it's not about this time. This time I want to talk about programming things. And I am a programmer. And speaking about programming languages, why they are called language? For the thing called language, you might expect words, sentences, paragraphs, rules and clear meaning, and clear rules and clear meaning, and I don't know, something like this, and just happy path and happy usage of the language. Everything is clear and structured and has a clear and beautiful meaning. Yeah. But in reality, we may find something a bit different, as you can see. And yeah. So the question. If language, why not language shaped? Why? What is this thing? How does it work? Why does it shaped like this? But as I said before, the main way to understand things is by asking questions and then trying to find the answer. So, why is this gibberish called language? That is the question. So I want to find the answer to this question. And to find the answer, we need some plan. And let me introduce my plan to our research. Well, the plan. The first point, the first step, to make a research about what is language. And this step, basically, I want to find some definitions. What is language? What its structure, properties, etc., etc., and basically to understand, to have some formal definition of what is language, what is called language. The next step, step 2, I want to compare language, in our case English, because I decided to choose English for this purpose. Compare English to programming languages. Yeah. So what is similar in these languages? What is different? And so it's our second step in our investigation why programming languages are called languages and whether they deserve to be called languages. Because I'm not sure sometimes. And the third step is to find similar rules to reuse our intuition. And what does this mean? If we compare English to programming and we find some similarities and find some similar rules, what I want to do, I want just to reuse my existing knowledge about regular languages, natural languages, and apply it to programming languages. Because why to learn things twice if I can just reuse my knowledge? That's the main point. So I need to find what is similar and what can be reused. And the fourth step is to create a mapping between both types of languages. What do I mean by mapping? Is if we have similar rules and conceptions, similar rules and concepts. So I want to understand which one in natural language is equivalent to something in computer science. So I want this connection. And the last but not least, I want to translate from English to programming. Because if you called language, I expect that you can be translated and other languages can be translated into you. So if you don't want to be translated, don't call yourself language. That's obvious, I guess. That's the fifth and probably the last step. But first we need to reach that fifth step. And so we need to start from the first step. Google or research. What is language? Research what is language. So let's start, basically. I already have some windows in my browser and some tabs in my browser opened because my beautiful and lovely software just crashed during the last session of recording and left me with my prepared tabs. So enjoy. Let's start. Let's start. Okay, so the first thing what I want to do is for just to find definition. And in our case, Google helped us. So we trying to find definition of language. The first definition is by Oxford Languages, and yeah, it sounds like the principal method of human communication consisting of words used in a structured and conventional way and conveyed by speech, writing, or gesture. Thankfully, we don't have speech or gesture in programming languages, so this part is not important for us. But okay, it's a method of human communication, okay, consisting of words in a structured, conventional way. Okay. The second one is a system of communication used by a particular country or community. Yes, to some degree. In programming, we also have some communities that speak only one language, one programming language. But yeah, that's not the important thing for us. What is the best definition of language? A system of conventional spoken, manual, signed, or written symbols by means of which human beings, as members of a social group and participants in its culture, express themselves. Yes, but not for our purposes. Too abstract and not for our purposes. We need something more formal. So we are technicians. We need something more formal. Okay, what is the simplest definition of language? The simplest way to define language is as a system of communication used by humans. System, communication, humans. Okay. Languages can be spoken or signed, and some have a written form. Okay. Written form is useful for us as a programmers or people who want to understand programming. And what is language in linguistics? Okay, linguistics. It's like more scientific stuff here. A system of spoken and written communication used by a particular country, people, community, etc. Typically consisting of words used within a regular grammatical and syntactic structure. Okay. System. Language is a system again of spoken, of written. Again, communication. Country, people, community. Okay. Consists of words and used within regular grammatical and syntactic structure. So structure, grammatical, syntactic. Okay. Okay, let's try. Well, the next one. Wikipedia. I like this one because of its brevity and clarity. Language is a structured system of communication that consists of grammar and vocabulary. It is the primary means by which humans convey meaning. We have something else there, but for now, let's be abstract and just use this one. I like this. I like this. So let's try our. Let's save this for now and go here. I will hide our plan for now and yep. Or maybe I will not hide our plan. Let it be, but I will move our definitions here. So we have definition for a language, but we have other stuff in this definition that also needs to be defined, like grammar and vocabulary. And I have some definitions here. A vocabulary is a set of words, again by Wikipedia, typically the set in a language or the set known to individual. Okay, so that's some set of words of a language, in a language, or some set of words known to a particular individual. Okay, this sounds good. Another one. Vocabulary is all about words. Okay, that's good. The words in the language or a special set of words you are trying to learn. Next one. Vocabulary is a list or collection of the words or phrases of a language, technical field, etc., usually arranged in alphabetical order and defined. Okay, alphabetical order. We have the word usually here, so it's not always, and it's defined. Defined is important thing. So yeah, and vocabulary is all the words of a language or the words used by a particular person or group. Okay, that sounds good, I guess. So, what do we know about vocabulary from these definitions? That it's a list or collection of words or phrases of a language, technical field, etc. So maybe programming language, and usually arranged in a alphabetical order. Okay, and also it's words of a language, or the words used by a particular person or group. Okay, so basically that's a set of words. Those definitions are not as clear as definition of language from Wikipedia, but let's get one of them. Anyway, we are not so specific here, and we can have some. We shouldn't be very specific and formal in our definitions and our use of definitions for now. So yeah, that's about vocabulary. Okay, and we have grammar. Okay, grammar is also very important thing here. So let's find grammar. Boom. Okay. So what Google, on behalf of Oxford Languages, tells us about grammar. Grammar, the whole system and structure of a language or of languages in general, so particular language or in general, are usually taken as consisting of syntax and morphology. Okay, including inflections. Okay, I don't know what is inflection. And sometimes also phonology and semantics. So phonology, it's about sounds, I guess, and semantics about meaning, morphology about structure of particular words or parts of speech, I guess, but it's too specific to linguistic. We need something less specific than this time, and more similar to our programming and computer science task. So let's try another one. The rules grammar is the rules about how words change their form and combine with other words. Okay. This one is a system of rules that defines the grammatical structure of a language. Grammar, the set of rules that defines grammatical structure. Okay. Grammar in linguistics, the grammar of a natural language is its set of structural rules on speakers, on writers' usage, and creation of clauses, phrases, and words. Okay. Okay. Well, let's try this one. Grammar, rules of language governing the sounds, words, sentences, and other elements. We don't have sounds in programming, thankfully. Words, sentences, and other elements, as well as their combination and interpretation. Okay, so we have words, sentences, and other elements. Okay. Yeah, not so useful here, but what I find useful is this one thing. Let's open it. Huh? This is a tree. More specifically, this is binary tree. And this is very good and very often used in computer science data structure. So this data structure, it's something familiar to me, and I have some warm feelings about this because I'm a programmer. I know it might look not very clear or obvious, but I will use it as a guide, and I will try to expand this structure. So expand those abbreviations, and yeah, maybe I'll try to make it more pretty. So yeah, let's use this one as well. So this tree shows us on one particular example, one particular sentence, how does it structure. So that's about grammar. And grammar is what we care about for now. And because it's a set of rules, and set of rules, that's a good, because what is our target? We wanted to find similar rules, and grammar is a set of rules, so yeah. Well, probably I will get some definition of grammar from here. No, not from here, but okay. Let's get this one. It's very clear definition of what is grammar. A system of rules that defines the grammatical structure of a language. Okay. Yeah. Eh? Nope. Copy and dude. Okay. Finally. Yeah. So what do we have here? We have a definition. And we have another definition in the form of binary tree, which I want to explain to you and expand. But for now, I expect that you might be bored a bit and maybe tired, because to be honest, I tired a bit after this stuff. Yeah, so I could use a break, and probably you may use it as well. So what do I usually do when I have a break? I want to free my mind from thoughts and just to watch and look at something beautiful, or listen, or just to free my mind and let it process this information that I collected. So let our brains process this information. And what do I want to do is I want to watch on some cats. If you don't like cats, or if you don't want to watch these cats with me, you can just skip to the next time code. You can find those time codes. It's in definition to this video. And yeah, but if you're still here, let's take a look at some beautiful cats. Well, oh, look at this gorgeous creature. Oh, okay, is it the same one? How do you think? Is this the same cat or not? Because it's no, I guess it, but I'm not sure. It's similar, but not quite the same. Oh, wow! They have those spots, or how would you call this? It's like the whole family of kitties. And this is I guess they are like siblings, and they look very similar. But for me, the left one looks like I don't know. Maybe the left one is female and the right one is male, or maybe not. I don't know. Maybe my intuition is not really great in this, but yeah, but these are two beautiful creatures. Oh, and this one is happy one. Nice. Red one. Okay. Oh, poor little kitty. Why? Why does? Why does you? Why do you look so sad? Oh, small little beautiful kitty. So sad. Why? I hope. I hope she's doing well. And then another one. It's good. Good camera position. It's like uh, it looks like this cat have like very long muzzle, and maybe for some degree, maybe for some degree it has, but I guess it's a camera position as well. You know, it's like when you're very close to the camera, like your nose, your nose looks much longer when you're closer to the camera. Yeah, beautiful, beautiful gray kitty. Gorgeous, gorgeous, furry animal. Just, wow, why so serious? Okay, I guess this one. And I guess this one has like this plush just tells it all. The same emotion on both faces. Yeah. Another one kid. And one black kitty. So, no, maybe my favorite one is this one for this time. I mean, this. Your face looks like just I can't understand my feelings about this face, but it's like too human-like. So I guess, yeah, that's my favorite for now. Yeah. And this one, I don't have my own cat, unfortunately. Hopefully, I will have sometime later, but I don't have my own cat. And my friend, he has like similar kitty, but smaller, younger. Also grayish, with a gray, beautiful fur, and yeah, very similar to this. But but her face is not so long. This kitty is just like trying to say, "Let me Google for you," something like this. It's but kitty version. Well, okay. I would continue, but but okay. I guess that's enough for now. This cat. Oh my god. Let's continue with our research and with our plan. Let's continue. Well, Okay, turning back here. I will not Google more than this. I guess that's enough for now. Most of the things, most of the definitions and other stuff, I will get it from my memory. So yeah, that was just the first step. And next steps. Well, the next step, compare English to programming. Okay, let's try to compare. But what can we compare here? Just English, like language, it's a structured system, which is programming languages are structured system as well, and of communication. I guess that's also true for some degree, because programming languages is something we use to communicate with computer. So we write our instructions, write our programs to communicate with computer, and yeah, basically that's one of the main program properties of programming language. And also we can use programming language as a tool, as a mean of communication between developers in the team. Because if you understand this, if you understand programming language, and you can just read and get the meaning of the program. So it's also some kind of communication, like written communication. So yeah, and it consists of grammar. But what is grammar? Grammar is a system of rules. And this system of rules, it contains many different rules, but also syntax. And syntax is a something that it's a rules. It's like subset of grammar, and this subset explains how can we structure our sentences and other stuff. Let me find one thing. So yeah, the syntax is a part of grammar that focuses on how words are combined to form phrases and clauses, and how those components are then arranged into coherent sentences. So basically, syntax helps us to create coherent sentences, phrases, and other stuff to be able to convey meaning. So that's important part of all this stuff. And basically, syntax is what do you start from when you trying to learn programming language? Because when you start learning some maybe Python, Java, C++, or whatever, it doesn't matter, but you will start from rules, how you can create variable or how you can create function, etc. All those rules, how you can create some kinds of statements, like if, else statements, conditionals, all this stuff. It's also quite similar to regular languages, because basically we got it from the regular languages. So yeah, so that's quite similar. And syntax is what you usually start from. So that is important part for our investigation, for our purposes. So let's try to expand this one. Let's try to expand this one. For this purpose, I maybe need more space. Okay, more space, and let's fill this thing. And like this. Okay. This one and like this. So, what do we have here, actually? The first thing. So, how do you read those things? We read it from top to bottom, and you can read it in layers, like the first layer and the second layer, and then third, etc. But here I don't like this arrangement, to be honest, because it's like looks broken a bit. It's the example sentence looks broken, so I want to arrange it a bit different. And yeah, and also you can read it not by layers, but from left to right. So just you have this root, you have the first thing S, which means sentence, and you can go left, and you have this NP, which means noun phrase, and then left, that, which means determiner. In our case, this determiner is the, etc., etc. And then you go this way, and then you come back and go this way, and then left again, left, and then to the right, and back, and etc. So let's do this. Let's do this. And let's start from our sentence. Well, sentence. Yep. Sentence, and let's make it like this and like this. So the sentence is our root. So the main thing we can use here is our root, the sentence. Next, what do we have? Is to the left we have NP. NP, that means noun phrase. So let's expand this as well. Maybe use like not so so easy to use one hand, but unfortunately I don't have my extent, so for now, yeah, I need to use one hand only. And we have noun phrase to the left, and we have VP here, some kind of VP, and this VP, it means verb phrase. So that's a verb phrase, and basically we have very similar structure in programming languages, but that's some spoilers. And okay, then after this noun phrase, verb phrase. So let's talk about noun phrase. Noun phrase in our case, it consists from determiner and from a noun. And what does it mean for us? Let's make it like smaller, maybe a bit. And put it here. So determiner is, if you Google what is determiner, in linguistics it's different things. So it can be article like here, it's like the or a or an. It can be different things like some, different words like some or what and other stuff. Yeah, so in our case it's the, and it's enough for now for our purposes. So let's use our determiner here. Determiner here, and put it like this, and our determiner is the in this case, and to the right we have an, which is noun, and noun okay, which is noun. Well, and we have our example, but I don't quite like this example. I will change it a bit. And let's talk about our verb phrase. Verb phrase. So let's put it like here. Verb phrase, it consists from a verb, as we can see from this particular graph, or not verb and noun phrase, not or, but this noun phrase here, it is optional. So if we Google, make our research, we can find some things about this stuff. So what can we find? We can find that sentence, it consists from noun phrase and verb phrase. And also it may consist from another kind of phrase, and all these phrases, they have their own special purpose in the sentence. We will talk a bit later about this. But what is important here? We have sentence. Sentence must have noun phrase and verb phrase. And noun phrase or verb phrase or any phrase can consist from one word or more. So it may be enough to use just one word in noun phrase or in verb phrase. And this part here, this another noun phrase, it's also optional. So in our case, we can build the sentence which might be simpler, like quite simpler than this, and it might be more useful for our purposes. So what I want to do is to simplify these things. So let's, in this case, try to use verb phrase, which consists just from from the verb, okay? And consists from the verb. And this verb it also can consist from this aux and some we. This aux is auxiliary verb. It's like special kinds of auxiliary verb, auxiliary word. It's special kind of word that we use in English grammar for different like forms on sentences for different times. And like present time and future, etc., etc. I'm not quite proficient in this, but if you Google and watch yourself what is auxiliary word, you may find more information. But for now, what do we need to know here? That this auxiliary word, basically, it's also optional. So we may skip it for now. And what do we know else? Okay, this we, it means just verb. So we have our verb, and we have it. This verb can consist from something, but in our case, it's just verb. So let's not expand it too much, and say that our verb phrase consists from a verb, right? And so what example can we use here to show that our structure is correct for English language? I would use example like this. Nope. Example like this. So for determiner, I will use the for now. And I want to change the color. For our noun, I want to use cat. And for our verb, I want to use the word meow. So but in English, we don't just use meow, but we say meows because the cat is because we're speaking about third person. So it meows. And basically, that's our example. And let's connect those things. I will use probably my tablet for this. And I want to group all this stuff so I can move it easier. One moment. So let's connect our things. So we have sentence, and we can, I don't know, maybe use some rectangle tool, and use a maybe this color. I don't know. Let's try. And there's no fill, and like this. Okay, and maybe use something like this. So what do you have here? Okay, that's fine. So the next one, the same, and the next one, the same. That's our parts, it's our structure, so I will use those rectangles to show our structure here. And noun and verb. Okay, I need my keyboard on the other side. Okay, so that's our structure. Well, okay, I will pause video for a while just to make it prettier and don't waste too much time here. So we'll see you in a moment. So a few moments later. A few moments later, and we have this graph. It's called tree graph. So yeah, basically that's our example of how can we use this structure of grammar. So that's our graphical definition of grammar, of one part of grammar, not the whole, but for our purposes it's enough. And what do we have here? We have at the top we have sentence, so that's the main part of language, and sentence consists from noun phrase and verb phrase, and noun phrase consists from determiner and noun. Verb phrase consists from verb and optionally from another noun phrase. It's optional, we don't have it here for now, so I just drew this empty box here. And and our example sentence is the cat meows. So the cat meows. Basically, that's what we will work with. Simplified thing. So let's distill a bit what have we learned during our googling and from this graph and all this stuff. So what do we know? Language is a structured system of communication that consists of grammar and vocabulary. Vocabulary is a set of words. Grammar is a set of rules. A sentence is the largest grammatical unit in language. I googled it. Sentence consists another part. We didn't Google this, but I did it previously. So sentence consists of a subject, predicate, and object. So in our case, but okay, not in our case, but subject is a first NP phrase, so it's our noun phrase, and predicate or just verb. And different in different articles and different definitions, we have different names, but it's called or either predicate or verb, just verb. This verb phrase is a predicate. And yeah, and we have an object. It's another thing. And we don't have the object here because it's optional. And later I will let you know what is it. So that's the structure. And yeah. Our first NP, I mean noun phrase. I started to abbreviate it as well. Our noun phrase, the first one, adds the subject, and it's a noun. And it performs at something that performs the action or is in a state of being. And verb phrase is a predicate, and it is a verb. And this it describes the action or state of being. So it's about action. So the first one, the subject, it performs the action or it is in some state. And the predicate it describes what action. It describes the action itself or the state of being itself, and the verb phrase. And the object is found in the predicate phrase, usually. This one, NP, for example. And so, yes, the object is found in the predicate phrase or clause and modifies the subject. So this one, it modifies our subject, our first noun phrase, but it's optional and we want simpler examples, so we'll skip it for now. So to not overwhelm ourselves, let's focus only on subject and predicate. And also let's use one-word phrases for simplicity as an example. The cat meows. So yeah, that's a minimal correct example for our rules that we find. The cat meows. Not that much, but that's a good starting point for us. So let's talk about a programming perspective. I'm going to show some programming perspective and map linguistic definitions on programming functions. So, like, it will help us. Yeah, maybe yeah, maybe I skipped one step, but we Googled, we compared, we found some similar stuff, I guess, like that both languages have grammar and syntax, and programming and natural languages, all they have phrases as well, and I will show this now and create those mapping between both languages in the process. So what do we have? Grammar is a set of rules a language follows to convey meaning. We have this in programming languages, and usually we use syntax for this. Sorry. And yeah, Syntax is a part of grammar that focuses on how words are combined to form phrases and clauses, and how those components are then arranged into coherent sentences. So there's another one. We have this thing. Usually you can find those information about the syntax when you learn your particular language. It can be found in documentation to your language, or you can find this in your programming language, like books dedicated to your programming language, etc., etc., articles and videos, a lot of useful videos on YouTube about this stuff. Yeah, so in programming language, syntax is basically the rules how you can create those phrases, like noun phrase, verb phrase, etc. Build statements or phrases or sentences, and how to structure them. So yeah, that's basically what is syntax in the programming. But let's talk first about particular parts of this. So let's talk about the subject. So our noun phrase is also called subject. It's also called subject. And we can create questions about our subject. And those questions are what or who. So what does something, or who does something, or etc. So that's a thing. So yeah, the subject is a thing, concept, or person that is doing something or is being in some state. And in the context of programming, noun is some abstraction that contains data. So what is important for us in programming and computer science? That subject or noun is some kind of thing that can contain data. In computer science, it's usually called state. So if we have some state or some object, something that describes and contains state, so that's called state. In practice, you can find this state under different names in different contexts. It can be object, one name, data structure, for example, list or tree or array, etc., etc. Also, state can be found in the form of variable or file or database, or even larger scale like data center, etc. So it's about state. So simply saying anything that can store data for a meaningful time in a given context, it's called state. And in our mapping between real natural languages and programming languages, this part, noun phrase, which is subject, it's called state in computer science. So let's show this. I will use this color for so our subject or noun, right? It is it is just a state in computer science. Yep. Okay. Now let's talk about another thing, about our predicate. So predicate is predicate is a verb and I will show what is it in computer science. So predicate is a verb, and we can ask questions about verb, like what to do, or what's done, or what will be done, etc. So if we ask questions about verb, it will be questions like this, about some action. So basically we speak about actions here in some active way, like run or meow, or in passive way, like exist or grow or just be, etc. That's a verb, that's a predicate. And in computer science, the predicate called action. So it's not like the main name, but that one of many which I find the best for our purposes. Yeah, so I will call this action, and in computer science, those things called actions. Okay, that's another one, and that's another one, and those actions in computer science, they have many different names in different contexts, and some of them are function or method or lambda or procedure. Also, it can be called predicate, just like in natural languages, or worker, or something like this. So some part of language on some level of abstraction, smaller or bigger, on different scale. Yeah, so this is called action. And basically, for our purposes, predicate means action in computer science. So, also speaking about word or phrase, let's make some simplifications. So, a phrase can consist from one word only, okay, and we can just use term phrase both for words and phrases, because if we can have a phrase that consists from just one word, technically one word is a phrase as well. So let's call words phrases in programming context. And the sentence, which is consist from phrases, it can consist from just one phrase as well. So if sentence can consist just only from one phrase, and in our case it will be like this, we can call sentence a phrase as well. Just why not? Just to be just to simplify things, too many different names for the same thing or for similar things here. And so either one word or a phrase or several phrases, we call them phrase, just phrase. And now, fun fact about this, phrase is also called expression, which is exactly how its equivalent called in programming. So we have phrases in programming, but we call them expressions. So let's stick to this name. And yeah, so we have sentences, phrases, and words, but they just called expression in programming. So we should live with this. And yeah. And finally, vocabulary is a set of expressions available in a particular language originally or created by a programmer from those original expressions. So in programming languages, we have some basic set of, let's say, actions or basically nouns and verbs. Yes, actions and some state. We may have this basic stuff in our programming language, which is a part of vocabulary of our language. And we can create new words, new vocabulary from existing one. So also very useful concept. And we do this very, very often. Much more often than in natural languages. Yep. And when we come back to our syntax in programming, in the context of programming and computer science, so we can say again that syntax is basically the rules how you can create state and actions, our state and action in computer science meaning, and build statements and expressions, or just only expressions, as like the same thing, statement and expression mostly, and how we can structure them. So it's all syntax about. Yeah. Well, nice. So we know that we have some syntax. It can be different from language to language, but we have those strict rules how to make this, how to structure our phrases, our expressions, and our expressions consist from subject and verbs, subject which are nouns and predicates which are verbs, and in computer science we call them state and action. So when we want to do something, when we want computer to do something, we need to have some kind of state, and we need to have some kind of action, and we want to combine them somehow using syntax rules. So let's recap again. The purpose of language to convey meaning or simply communication. Language works with sentences using grammar, syntax, and vocabulary. Sentences consist of phrases or expressions. Can be just one phrase. Phrases consist of words, can be one word. Word is a basic element that carries meaning. And by type of meaning, words are classified as nouns, verbs, and etc. That's parts of speech, which in their turn I just connected to particular computer science concepts. So I connected what is subject, what is predicate, and I connected what is nouns and verbs, and what is language, syntax, and phrases. Wait a moment. So programming languages are actually languages. Seems that's true. But now we have another question. Who we communicate with? Okay, we answered it. We communicate with computer or our system, machine, or group of machines, and we give them instructions. And also, not directly, but also we can communicate with other programmers. So they can read our code and understand what did we mean, or don't understand if we write our code not very clearly or meaningfully. Yeah, so basically we communicate with computer and other people, other programmers. And another question. If language, so it should be possible to translate it. And we come to our fifth step here. If language, it should be possible to translate into it from our English. So let's try to translate our example phrase, the cat meows. Let's try. But let's take a break. Let's take a short break. As I said, if you don't want to stay with me during this break, you can skip using time codes in description. Just go to the next part, where I will explain how to translate from English to programming language, and where we will create our small but useful enough language, and hopefully we will translate from English our example sentence, the cat meows, to programming. That's our main goal today. But first, short break. Okay. Our short break. Let's drink some water. Nice. Ginger cat. I know that in the internet there's some belief that ginger cats are very active, maybe too much active, but this one looks very calm, I guess, and beautiful, small, beautiful, furry animal. Nice. I like them. I like them all. Oh, this one. We have some story here, I guess. I don't know exactly, but this looks like a painting, and they think about their own stuff, and and the gray one doesn't look very happy, I guess. And maybe that's just one moment before the culmination, one moment before the fight, I guess, because sometimes it looks like this. Okay, hopefully they didn't fight. And another one beauty is a kitty with a small little bell on her neck. Also looks nice. Okay. Oh, this one, so small, beautiful guy. It has this like different eyes. Heterochromia, I guess it's called. Heterochromia. It's one eye is blue and another one is green. It's looks beautiful, and yeah, but as I know, sometimes these cats have some difficulties with their eyes, and yeah, so hopefully this one is healthy, and his eyes are okay. I hope so. This one is, yeah, this older one. Yeah, grandfather, I guess, or grandmother of all the kittens. Yeah, it's just having a nap. Yeah, that's nice. It's nice to have a nap when you're a kitty. It's nice to have a nap where you're a human, but it's not always possible. But while our cats can do this, let them do. Another one, beautiful guy with a whitey face, muzzle, and white and black. And this pose, oh, this pose. As I said, I don't have my own cat, but my friend's cat, I visit him from time to time, and I see her kitty. I see his kitty, and she has so soft paws. She has those not even paws, like not under the foreleg, but this part, like top part, it is so soft. I just cannot. I have nothing to compare this, but it's. I don't know, it's just so soft and beautiful, and I just can touch it for hours. I don't know, and it's this pose is just something I like so much. And what is this? Okay, this is great. Those teeth. Okay, it's like Graf Dracula, and this is just great portrait. Just great portrait. Okay. Okay. Well, yeah, we had some more cats. I guess it can be considered like a small break, and hopefully our knowledge processed for a while. Our brain processed this knowledge, Well, let's come back. Let's try to come back from our kitties to our sentences, to our languages. And let's try to translate. Let's try to translate our example sentence. So, what programming language should I use? I thought about this for a while, and I know different languages. I know JavaScript, Java, Python, like HTML, CSS, etc., etc. Like quite a few languages, but I don't want to discriminate any language here, and so I won't use real one for several reasons. First of all, I don't want people who learn different languages to feel discriminated about their own language. And I think it's not so important to use some real particular languages to get the idea of how does it work. So in this case, I will try to create some simple, maybe simplistic language. So we can just explain how it could work, how can we translate from one language to another, from natural language to programming language. So let's invent our simple language for our modest purpose. First, we need to translate our subject. In our case, it's the cat. First, we need to translate our subject. Correct window. In our case, it's the cat. And the simplest and reasonable way for this purpose is to create a variable. Because as I said, our subject, which is state in computer science, so let's call it state, it can be in different forms, like files, databases, etc. But in our case, the most simplistic form is variable. So yeah, in programming languages, variable is something that can contain our state and that has a name. So variable has a name and can contain our state. So let's show how our variable can be created in our language. I will expand our canvas a bit. And check. Yeah. Okay. Let's use this space. Okay. We have our example, the cat meows. We are trying to translate the first part. We need to create a variable. And to create a variable in our language, which is not a real language, but still, we will use such syntax. Well, we will use a keyword variable to show that that's a variable. And we will use we will have a name, but I want to change the color to, I don't know, maybe minty, something minty. And the name of our variable will be the cat. The cat. And I will not use a spaces. Instead, I will use underscore here, just because it's easier in programming languages to parse our language. To parse, it's easier to automation tools which we may use for our language to understand which part is a variable, which part is something else. And if we have spaces, sometimes it might be more difficult to understand where the name started and where is its end. So usually in programming languages we don't use spaces and keep those names like in one thing. So one of the ways to do this, just to use underscores instead of spaces. So that's how it looks like for now. And also we will have a data, because we want to store something here, or maybe call it more explicitly state. Or maybe data. No, I guess let's call it data. And use this minty color again for the name of the thing, and our data. What do we need? Yeah, let's use some indentation. So what data do we need to know about the cat? For now, that's enough to know its name maybe. So what data can we have? We can have some kind of like size of the cat, maybe its position and color, and etc, etc, etc. But for now, for our particular example, we just need to translate the cat to our programming language. So let's call it just like cat name. Cat name. And this name, wait a moment, and this name is just like the cat. Yeah, it's not very easy to type with one hand. Yeah, so cat name. Let's make it like this color, and the name itself is the cat. That's enough for now. That's enough for our purposes. So we declared this variable. It starts from the keyword variable. So we know the type of our abstraction, because this is abstraction of our programming language. And also it has property name, which is the name of a variable itself. And we will use this name to reference to the cat later. And it has the property data. And this data contains important to us properties that are important to us and that we want to know about our cat. And in this case, I decided to know that this is the cat. It's his name, the cat. So cat's name, the cat. Maybe we will change it later, but for now, it's just the cat. So, what do we need? What else do we need? We have this one part, the cat, which is the subject or state. We need to translate our predicate or action. So we need to create from a predicate in natural language. We want to create an action in programming language, right? So we created from a subject, we created state, which is our variable, and from the predicate, which is mouse, we want to create an action. Let's do this. And I will copy, I guess, our variable thing. I will copy it and call it action. And let's create our action. To have the action, what do we need? We need the keyword action. So we know that that is action and not a variable. And we need the name for our action. And what name to use? In previous example, in this variable, we just got our cat's name, like the cat in our case. We just got our subject and used it like name. Let's get our predicate and use it like a name for our action. So we will use meow. Meows. But we have meows here. But in programming, usually we don't use the third person stuff with s and all the stuff. We just used the regular verb like for the first person, like just meow. You can use whatever you want, but usually there are some conventions for each language where all those rules are explained. So what is better, how it's better to name variables and actions and other stuff, etc., etc. For different languages, it's different. And it changes quickly sometimes, and what was good for one language may be bad for another one. And if you need to switch between languages often, it's annoying thing a bit. But just what I do and what I would suggest to you, just be consistent. Just be consistent in your code, in your language, your programming language, and use of language. Be consistent. So if you name variables in some one particular way, do this for any other variable. And if you name actions in one particular way, whether from the capital letter or not, or something else, doesn't matter. Just be consistent. Be consistent so you don't confuse yourself and others. So yeah, our action. We have a name for our action, meow. And what else do we need for the action? To perform the action, we need to know who is the subject. Because we know from previous definitions that the predicate, it explains the action. It explains the action which is done by or to our subject. So we need some way to let our action know what is the subject. One of like regular way, often used way, is to have some input to our action. So if we have input, and I will use this color as for our properties, we have some input. And in this input, we need to have some useful information that we need from the start of our action. So it's required for us to perform our action. And let's leave it empty for now. And in our action again, we will need some steps. So we need to explain, we need to define what is our action, what our action is, and what is the algorithm or steps we need to perform to do this action. So we will have steps here. We will have steps, our steps here. So for input, we will have some cat, and this thing, this some cat, is also variable. So for input, we will have like a variable. Let's use white color here because it's not a definition, like variable. It's not white. Maybe this. Okay. Just use variable with name, just any variable, and we will name it some cat. Because to be honest, we don't really care about the name of the variable. What we care about, what do we care about, is what does this variable contain? And our variable contains cat name. And that is important for us. So we will have this some cat as input. And this should be variable. And our steps to perform this. Let's say like maybe let's be like abstract here without some very specific things, and say that we have just one step, and this step is say meow on behalf of some cat. Of some cat. And now let's make it prettier. So say meow on behalf of, let it be white, on behalf of some cat. Let's use the same color as here. So we have our some cat, and we have the same variable here. We use it. So say meow on behalf of some cat. That's our action, basically. So we have a keyword action. We have property input, which contains the data input required to perform the action. In our case, that's just one variable, some cat. It may be more, but for now, it's just one variable. Also, as you can see, the action does not contain any data or state itself. It doesn't have own data, and it uses some external data, some external input to perform this action. So in our case, our action doesn't have its own state. So why? Because we want to mimic our natural language. And in our natural language, the cat, the part of state, which is state, and mouse is a predicate, and it does not contain state. That's nothing about state here. So that's why we have this input. So we just declare that to perform this action, we require this input. So if you want this action to be performed, give me required input. Otherwise, our action either won't work or will work incorrectly. Or maybe it may use some default definition of the action. But in our case, we just have this input and we will provide it. So, yeah. So that's what we have in our case, in our simplistic example. And also we have the property steps. And in real programming languages, we also have this part. So it's basically our computer program, our instructions. What do we need to do to perform the action. And yeah, and in our case, it's just one step. I used just regular language. And yeah, say meow on behalf of some cat. That's what we need. Um, so we have our variable and action, and giving them names and type variable or action. So we have type variable, type action here, and we have name here and name here. Giving them those type and names is called declaration. So we declare them, and giving them other properties like data here or input and steps here, that's called definition. So basically, we are creating our vocabulary here, like we have seen before. In vocabulary, we have some word or phrase and its definition. So its meaning, explanation of what does it mean. And here we have just the same thing. We have like variable and its name. It's like the word, our word, and other stuff like data here or like input and steps here is our definition of this word. So what does it mean? And we explain it to our computer. So computer understand what exactly means, what's the meaning of the cat, or what is the meaning of meow. Yeah, so it's what we are doing here. And declaration and definition is the actual terminology in programming. So it's what do we use, and it's very similar to regular words, to regular definitions. Like a small example. For example, I have a definition from English. A line. So a line is a one-dimensional figure which has length but no width and extends infinitely in both directions. So this is a line. This is geometrical definition of the line. And a line, just words a line, its name. It's basically this. And in our case, a line is a noun, which is may be subject in some cases. And yeah, so at some point, probably thousands years ago, someone invented and declared this term line and gave it a definition. And in programming, we do exactly the same. We invent words or phrases and we give them definition so we can speak to the computer and to each other in some indirect manner. And we can reason about our subject, about our program, and about our tasks, etc., etc. So, we have our words. That's our vocabulary. So, we need to create our sentences, phrases, words, which we will call expressions. And for now, let's have some basic syntax rules. How can we combine our words to to convey meaning, to convey required meaning. So I suggest to use such a structure. So we would use like action name, um, and after the action name, in parentheses, we can put our input, required input. In our case, that's one variable, the cat, because we don't have other variables, but it can be another variable related to cat. But in our case, we have just this one, so we will put this one. And yeah, basically this is an input. So here we may have like input. Like this. That will be our structure or our sentences. And let's use this structure, and we have action name. Our action name is meow. So let's use this name, meow, and we have an input for this action, which should be some variable of some cat, and we have one, we have this one, and we will use this variable also by name, because that's how we refer things, how we refer our words, by name. So we will use our declared previously variable, the cat. The cat. And in regular languages, we usually put a dot in the end of our sentence, or maybe exclamation mark or something like this, but we put some symbol to show the end of our sentence. In programming languages, it depends. Sometimes you can put this symbol at the end, and usually you will see like this one, like semicolon. But sometimes you don't. And it depends on the language. And some languages just let you either put this semicolon in the end or not. And I will not put it here because we don't have the dot in our example. So let it live without the dot, without the semicolon. And basically, what do we have here? Here, let I want to break free. Okay, and yeah. What do we have here? We have the sentence, the cat meows, which is our example sentence. Let's copy it. Let's copy this sentence and put it like, nope, technical difficulties. Excuse me. The cat meows. Let's do it another way. Let's do it like this. I will use just screenshot of this and copy, and I will put it here. So the cat meows. Is a translation that is translation of let's use this color and so yeah, basically what do we have here? We have our sentence in English, the cat meows, and we successfully translated it into our programming language, which is looks like this, and we have our words, and we have our expression, which is sentence. Nice. And yeah, basically that's it. And now we can say that programming languages are actually languages, and they not just pretend to be languages. And if we know how to reason about those languages, and if we know how to structure them correctly and clearly, we can have much prettier code structure and much clearer structure of our code. And that's what I'd like to show you in the future. And this small, beautiful sentence, the cat meows, is our starting point. And I believe I have to say much more about this. And I can show examples in different languages, in real programming languages if you wish. But the main point here is that programming programs, they shouldn't look like some nonsense. They shouldn't be ugly and unstructured and all this stuff. It can be as a language, as a regular language, also can be ugly and unstructured and don't convey the meaning. But usually we as people try, if we want to communicate, if we want to make it efficiently and clearly and maybe pretty for some way, in style, in some style. If we want all this, we learn how to do this. We use some special structures, we use some special rules, etc., and we find our style and we stick to it. And that's exactly the same how you would behave, what you would do with programming languages. And again, this might look small, but for me that's exciting because programming languages are not just something that it's not a black magic. It's just a language. And if you know rules, if you know vocabulary, if you know how does it work, you can use it. And you don't need to be extra smart. You don't need to be of some special kind of mind that can process all these words of knowledge and etc. etc. No, it's just a language. You can learn it, you can translate from one language to another, and that's the point. So I hope it wasn't too much boring, and yeah, I hope, but it wasn't boring for me. So hopefully someone, maybe you, will find this as exciting as I find it. And let me know if you want more videos about this particular topic. And let me know what do you think about this video of this particular example and explanation. As always, I would like to see your feedback. Let me know if you think that I could do something different, better. Yeah, so that's it. Thank you for watching and good luck. Bye.